inductees, and we're given a blood test to determine their blood type for the data set below, so we know what their blood type was, and I want to construct a frequency distribution for the data. So this is for my categorical data. So in this case, we don't have to worry about those class boundaries and things. We just need to worry about the categories that we have. So we're going to make our classes. And in this case, our classes are our category names, so we're just going to use our blood types. So the A's, B's, O's, and AB's. And then we're going to have our frequency counts. All right, so how many A's do we have?
5.
How many?
5.
5? And that's just going through and adding them all up. How many B's do we have?
7.
All right, how about O's?
9.
And AB's?
4.
Does that add up to 20? 25? Oh, that's right, we want to go to 25. And it should. So if you left anybody out, then it will, you won't have enough. And you should be able to add that column of numbers and get back to the total amount in your sample. So for a category, there's not much to it. We just need to go ahead and put our frequency counts in there and get our categories lined up. Now, just because we can, I didn't ask for it. If it just asked you for a frequency distribution, that is my frequency distribution. If it asked me to find the relative frequencies, we'll just extend this. We still need this basic part, but we could get the relative frequencies. And that's going to be where you divide. So we said we're going to take the frequency count for each category, so 5, and then you're going to divide by the total. 5 divided by 25, 7 divided by 25, 9 divided by 25, and lastly 4 divided by 25. And those should give me some sort of decimal. So let's see what that gives us. 0.2. How about 7 divided by? All right, and 9, and 4. All right, and due to rounding, it might not work exactly, but it should add up to 1 most of the time. If you're off by a little bit and you get 0.999 or something like that, or even 1.01, it's just because you have to round somewhere unless they actually come out to nice numbers. If you don't have to round, they should come out to exactly 1. So it shouldn't be too bad. And then just because I have the relative frequencies, you can turn those into percents. How can we get our percent frequencies? Times 100. So we could get 20, 16, 28, and 36, and these are now all percents. And that should add up to 100%, ideally. Now I will specifically ask you if I want the relative frequency or the percent frequency. It'll say build a relative frequency distribution or build a percent frequency distribution. You'll need the pieces before it in order to do that, but if I just asked you for a basic frequency distribution, you just need this stuff in red. Questions on that? All right, let's take a look at data. When we have quantitative numbers, what do? We need those things with our classes and all of that. So this data represents the record high temperatures in degrees Fahrenheit for each of the 50 states. Construct a group frequency distribution for the data using 7 classes. So grouped frequency is the same thing as just a frequency distribution. You just need to make your groups and your classes. In order to do that, I need my class width to start this. So the class width was I needed the maximum and the minimum data point first, and then I would divide by how many classes that I want. So first off, what's my maximum data point and what's my minimum? Minimum's 100. And we've got 134. Is there anything higher than 134? So we have a max of 134. So I can get my class width by saying 134 minus 100, and they want 7 classes. So we want to divide by 7. So 34 divided by 7 gets me to 5 point something, right? Or sorry, 4 point something. $4.856. Okay. So I don't particularly want to add decimals in yet, and in order to make sure that I have a high enough upper limit for the last one, I always round these up. Even if that wasn't a 0.8, say it was a 0.4, I would round it up to 5. And I'm going to use a class width of 5 for this. All right, so then I need to build my class limits. And we're going to have a lower and an upper. Now, we already decided that our minimum data point is 100. So there's really no point in starting below 100 because that's the lowest we can get. Then my next lower limit is a distance of 5 away. So you're going to add your class width to get your next class limit. So we've got 105, 110, 115, 120, 125, 130. Is that 7? Yes. So you add that class width till you get to the specified amount of classes that they say they want. And those are all your lower limits. They're not your upper, they're all your lower. To get my upper, I want the highest whole number I can get to without pushing me into the next class. So what's the highest I can be without going into 105 as far as whole numbers go? 104. And then I can always think of it, I can add that class width to get all the uppers from there. I can also say it's always 1 less than the next lower limit, if you want, either way you want to think about it. So then I need 109, 114, 119, 124, and then, did I skip one? Nope. 129, there we go. And then your last one should be the same distance of 5 away, so 134. And notice that it is high enough to contain our maximum point of 134 in there. I didn't draw these very even, sorry about that. All right, so these are my different intervals, and I want to be able to find the numbers that are in between them. So we want to be able to find how many numbers are between 100 and 104. So this is the fun part. Now we get to surf through the numbers and decide how many numbers are actually in between there. Ocean predictor at the top of the food chain, or predator for the top of the food chain. Here are the lengths in feet of 44 great white sharks. The individuals in this data set are individual sharks, and the variable is the body length in feet. And I want to create a frequency distribution for this histogram with 7 classes. So that means I already know how many classes I want, so I need to figure out the class width and then build my limits from there. And because we have decimals, we're also going to need to build our boundaries to get rid of any uncertainty of where a data point should go. So let's figure out what our width is, which means we need our minimum and our maximum. So what's our minimum data value? 9.4. What's the maximum?
22.8.
And we want to divide by 7 because that's how many classes we want. So what would our class width be here? $13.4? Yeah? Really? That's the top number if you subtract them? All right, so you still need to divide by 7.
1.92.
So we're going to round that to 2. So we'll have a class width in between of 2. And again, I'm going to start my class limits at the minimum because there's no reason to go any lower than that. So we'll start at 9.4. And then if I add 2, we'll get to 11.4 and 13.4, 15.4, 17.4, 19.4, and 21.4. Then at first I'm going to have a